Hello and welcome to CapTech's Talk Plugged In. It is now 3 p.m. in the Eastern Daylight Time for the United States. But whatever time it is for you locally, we welcome you and thank you for joining us. My name is Cameron Newsom. I'll be the webinar host today. I'm the Director of Admissions at Capital Technology University. I am pleased to welcome you to the second webinar in our CapTech's Talk Plugged In series. The third webinar. The Plugged In webinars are designed specifically for high school and community college transfer students and hosted by Capital Technology University in Laurel, Maryland. Webinars are presented by current and former students as well as alumni and staff. Today's webinar is CapTech Robotics Project Certificate Series number 1, Capital Technology University, A History of Student Innovation. Okay. We have a total of 8 webinars planned for this fall. This is the third in the series. I will talk more about the upcoming webinars at the end of the session today. We welcome you to this special presentation and are pleased to have current Capital faculty, Dr. Vijay Kowtha, as well as Leslie Gruss. They will be presenting today, again, the CapTech Robotics Project Certificate Series number 1, Capital Technology University, A History of Student Innovation. Here's our agenda for today. We have a word about our university, a bit of housekeeping, then our presentation. We'll follow that with Q&A for a period and then wrap up with some information about our upcoming webinars and any recordings, slides, and certificate information will be sent to you after the event. So just wanted to go over a quick word about the university. Capital Technology University is a private, nonprofit, and accredited university located in Laurel, Maryland. We have both regional accreditation, which is the highest level of university accreditation in the United States, as well as authorization from the state of Maryland to offer associates, bachelor's, master's, and doctoral degrees. We are an award-winning university. And the only private college in Maryland focused specifically on STEM degrees. So please consider checking out our website or calling one of our admissions counselors. There is a page on our website where you can actually make an appointment to speak directly with an admission counselor that is specifically recruiting in your territory. Before we begin, I want to cover just a few housekeeping items. If you have any questions during the webcast, you can type them in the question box and submit your questions for the presenter. We will use that chat box for information, but if you have a question, use the question function. That allows us to better manage questions. We are not enabling audience microphones or webcams for this webinar. You can submit questions at any time, and we will try to answer as many of them as possible at the end of the presentation. A follow-up email will be sent to all registrants with the on-demand link to the recording and the slides. And we encourage you to email the host to let us know how we did. We do strive for continuing improvement, so we are looking to evolve beyond this. And by the way, the entire session, including the Q&A at the end, should take roughly a little less than 60 minutes. So now to our presentation. I just want to introduce our presenters today. For session 1 of this 4-part series on honoring a robotics project certificate. Today's session is called Capital Technology University, A History of Student Innovation. The overall coordinator for the robotics project certificate series is Dr. Vijay Kowtha. Dr. Vijay Kowtha is a strong and visible leader in the support and encouragement of young people in their studies in engineering and specifically in formulating areas of responsive research. After completing degrees in applied mathematics and electrical engineering from NYU and Rutgers, he's been in federal research at the Office of Naval Research and Naval Research Laboratory. He's also been active with Sigma Chi and the Washington Academy of Sciences. Dr. Kowtha has judged in interdisciplinary science panels for Washington Academy of Sciences over the past 20 years. And over the next 4 weeks, Dr. Kowtha will lead a group of panelists who will join him for the presentation. Today, he's joined by Leslie Gruss. He will introduce Leslie a bit later in the presentation. So we want to welcome Dr. Kowtha and Leslie Gruss. to our presentation, and you'll hear from them now.
Thank you, Cameron. It has been a pleasure working with you at the local First Robotics and VEX and FTC events. So we want to spread the message of Capital, and Capital has been with us for the past 2 decades as we mentored middle and high school students in robotics over the 2 decades here. Hi, I'm Vijay. I've been associated with a school called Eleanor Roosevelt here in Prince George's County. I was their PTA president, and I, through the years, made friends in the robotics clubs. And then we brought the first robotics competition to Maryland from Virginia in 2000, and I have a video to show off that. But before that, I want to show you the description of this picture on the left. The young man who's running is Mr. Eugene Ritsky, and the big Texan is Jack Tinsley, a student at Capital. Again, this was the history of Capital when it was at the Washington, D.C. Naval Research Labs. It was called Bellevue Radio Materials School. This was founded after World War I. People moved from Great Lakes, Michigan to D.C., and they were in all aspects of engineering and the technology then that IEEE or IRE was interested called radio, wireless and radio. So Eugene was the one who would, Mr. Ritsky, the person as a master chief, encouraging students like Jack Tinsley was a sailor. And the thing Eugene had was a car. So in DC, in Bellevue, where they were in Anacostia, he was the only one who had a car. So for them, that was their salvation, that they needed to listen to Mr. Ritsky. And listen, they did. So we want to bring that glory back of history, but also tell you that in the 4 weeks that we will be with you, we'll be describing sessions. One today with Leslie on history, STEM, ethics, privacy, that Leslie will cover, and importance of notebooks, the lab notebooks. And of course, we will be describing the PiMars Robot that we have built specifically for students. And you guys can do what we will show you in the video right now in the 3 weeks that you will be joining us and hopefully get a certificate out of it. You will be mechanical programmers, you will be sensors designers, and you will be driving these robots from your home virtually to our makerspace. So Mazer is a nonprofit that I started with Leslie a year and a half ago, but we have been mentoring in the community. So I have Anurag, I have Steve and Leslie who have joined. They're part of Mazer, and they are local and they want to volunteer and spend time with you. So now I'm going to introduce Leslie. Before Leslie, I'm going to show the video of the first robotics event that we participated over the time. And the key here is robotics is fun, and we want to get that feeling of it. And so I wanted to give you a video.
Chesapeake, I think, has a couple of unique things. One is the venue here.
Welcome to the Naval Academy. And I can't tell you how happy I am as the Dean of Engineering at the Naval Academy to welcome the next generation of engineers and scientists here to Annapolis.
You can do something that's hard, you can do something that's difficult, you can do something competitive, and you can enjoy it.
We are not seeing the video.
Students really enjoy being able to compete, but also learn from each other. And this year's game, Rock and Roll,
you need to share the video.
Played by 2 alliances, a Red Alliance.
BJ, we are not seeing the video.
The energy and the commitment and the dedication that I'm sensing here shows me that this.
Vijay, we still need to see the video. You'll have to share your screen. Vijay, can you hear us?
I think we lost the slides.
Yeah, we couldn't see the video. You needed to share your screen.
Oh, it's okay. Can you see it?
Yep, we can see it now.
Is that the students are helping each other in every aspect.
Volunteerism is the name of the game with FIRST, and there are many people deserving of recognition.
Put another hole on that side so we can put another screw in there.
Well, you know, if you're looking for a part, you just go up there. Next thing you know, you see 7 different teams coming with the same part, trying to help you out.
Team 75 needs 2 6-inch sky wheels.
Your judge advisor, Carolyn Van Dam.
Hey everybody, we are so glad to be here today. You guys recharge me every year.
That's good. How many team members do you have?
It's been a lot of fun. Working with the judges has been really excellent.
Yeah, we had to get over that, you know, we had to start loving these guys.
It seemed initially to be all about the robots, and then once I got on board, I found out that, unlike my initial expectations, that it was not all about the robots, that it's about inspiration, and it's about the teams.
The students are incredible, and they always give back more than you ever can give them.
I want them to know they can do anything they want. There's opportunity out there, and they're capable of it, and I want them to feel free to talk to adults and tell everybody how excited they are about science and technology.
My mentor is Mr. Marvin Todd Martin. He is strong, but he is also very, very kind.
And mentoring is more of an art than a science.
Don't worry about the coders.
Oh, they did an excellent job, you know. They did beyond our expectations. They met all of our expectations.
You should be proud. You should be proud of the amazing feats that your robots performed. You should be proud of the teamwork that you displayed.
This is just the beginning of possibilities. They just have this glow of excitement about what they're doing, what they're talking about.
As soon as you go to a first competition, you know you thrive on it, and you want to come back the next year and the year after that. You want to see as many first competitions as you can.
So the upshot here is that Capital was there for the past 2.5 decades, allowing us to pick up the kit of parts. We have used Capital for training students, and they have shared the spaces so you guys can learn. And this is what we intend to provide in our activity. And I'm going to introduce Leslie now, who's part of Mazer, to get the STEM part started. Leslie.
Thank you, Vijay. Hi, everybody. I want to talk a little bit about how I got to the point I got to in my career. So my PhD is in applied mathematics from Northwestern University. I ended up going to work for the government. I worked for the government for 30 years. I worked for the National Security Agency, and you might wonder, how did I ever get to that point? So let me talk a little bit about me. So I imagine some of you out there have seen movies about Jason Bourne or you've seen the movies Mission Impossible, or like me, you might be a James Bond junkie, right? You love watching James Bond movies, right? So I grew up in the era when I was a little kid in the 1960s. That was an era of the Cold War. And so all the TV shows, a lot of them were about spies. And so as a little kid, I watched a show about a law enforcement group, which was called The Man from U.N.C.L.E., which you can still watch on video these days. And it was all about protecting the free world from the evil agents of Thrush. It was a very thinly veiled story about the United States against the Soviet Union. And as a matter of fact, you would know one of the characters even today. So for anybody out there that watches NCIS, the character Ducky was actually one of the characters on The Man from U.N.C.L.E. way back in the 1960s. So he looks eternally youthful. It's completely remarkable. But in the era I grew up, which is shortly after the era that Vijay talked about, they had taken all that wonderful electronics and radio technology, and there had been a whole bunch of inventions during World War II that made it possible for us to come up with things like electronic bugs and surveillance systems and miniature cameras. And so that's the world I grew up in. And so I wanted to be like the Man from U.N.C.L.E., which is kind of how I got down the path of having a career at the National Security Agency. Could I have the next slide, please? So I've already talked a little bit about myself, but let me give you a little more detail. I grew up in Washington, D.C. on Capitol Hill, 2 blocks from the Capitol building. I went to a girls' private school in D.C. where I studied algebra and trig and calculus and physics and chemistry. And I ended up going to the University of Chicago, where I got my Bachelor of Arts degree in mathematics. And then I went to Northwestern, where I got my PhD in applied mathematics. I also did a lot of teaching at that point in time. I was teaching calculus. After that, I eventually went to work at the National Security Agency, where I worked for 30 years. And the great thing, of course, about being a mathematician, as Vijay will agree with, is that it gives you a license to interfere in anybody's project that you want. So if you see something interesting going on in the physics lab, well, by all means, you have a credential, you've got a math degree, you should go and interfere in that. So while I was working at the National Security Agency, the great thing about my math degree was I got to work in lots and lots of different areas. So at one point in time, early in my career, I decided I was interested in signal processing and electrical engineering. And NSA sent me off to learn about electrical engineering at its expense and paying my salary full-time. And I went to the University of Maryland for a year to study electrical engineering at the graduate level. So another summer, I was doing a project where the physicists were indeed doing an interesting project, and I got to work with the physicists. I also worked with computer scientists, computational linguists, regular linguists. I did all sorts of fun things. I had a ball. And the secret, I guess I would share with you, was that I was brave enough to go ahead and try something new every couple years. So I never got stagnant. I always came to a new problem, which I had to learn something about and contribute something new. Could I have the next slide, please? So what does NSA do? So as you all probably know, NSA is located at Fort Meade, Maryland, which is not very far from where Capital Technical University is. And they actually do have a lot of summer internship jobs. And they also have development programs in cybersecurity as well that they offer. But NSA's core mission was originally in cryptology. So cryptology is the making and breaking of secret codes. So I put the English definitions here. Cryptography, that's the design of codes to preserve secret messages. And cryptanalysis That's the breaking of codes so that messages can be sent in secret. Next slide, please. Over to you, Vijay.
So Leslie, Anurag, who's on this, and myself are part of Mazer. So we started Mazer in Prince George's County at Eleanor Roosevelt, Area 53. And the person you'll be meeting next week, Steve Lavallee, in Team Illusion and Parkdale for past 8 years. And then we got in Bowie, Duval, Oxon Hill, and with Leslie, we started a girls team called the Blade Runners. But the key here was that we could use Capital students to mentor. We had Capital students build the robot in 3 days on campus. The beauty is these students spend time and learn and build these. So we, instead of 3 days, we had a working robot on the first day itself. On the Saturday, when kids come to Capital to pick up their kit of parts, we had a working robot driving on the first day itself because the students at Capital were there, excited, and were part of it. And the other part was the students wrote the code and did the diary of the lab notebook. And one of the students won the award for the DCCAS Science Festival, where they were students who have written up papers were honored. So this is, the slides on the right is Department of Defense funded robotics clubs. And so we helped Eleanor Roosevelt, which won the national championships twice, and Epcot Center. And the best part was we brought FIRST Robotics to the Naval Academy and throughout Maryland. It was in Baltimore, it was in Prince George's County, and then in DC Convention Center. So we enabled it as mentors. As Mazer, we provided students, we provided resources, and we had a fabric of students who would then go to Capital because Capital would fund, because they were there with us all along, and students who were part of the clubs got scholarships to come to Capital. And so that's the connection. We have been involved. And so the students would showcase what they have built throughout Maryland, be it at the Engineering Week on Discover Engineering in Baltimore or in DC, the Association of Crows Robotics Showcase that Leslie and I put together last 3 years. And then at the Gaylord Hotel, we had the Sea and Air Expo. So these are ways where you can showcase your work, and similar to the excitement of FIRST Robotics video that I have shown, we will have another video like that for our event that we want to work with called PiMars. But the key here is that it takes a lot of struggle. It takes a lot of individual entrepreneurship from students, and we are here to help over time. And as Cameron said, the FTC district events, the robotics what happened locally in DC, and you were part of, as a high school student, involved in there. So this is the connection between college and school that we mentor, and we as Mazer, we work with Capital because we have a memorandum of understanding, MOU, so that we can work with Capital students as a nonprofit. So we are mentors advancing STEAM education. The difference between what we did 20 years ago when we got robotics to Maryland was that was inspiration. Now what we are doing with Leslie and the gang is to get you guys to publish. So you can wait until the 4th year at Capital when you do the senior design for your capstone, but we give you opportunities as mentors to go into areas that you would want to work in and take leadership in that role. So we have a student that will be presenting next week, Daniel Johnson, who's doing his senior design on space robotics and all the way trying to study signals from outer space, what we call Search for Extraterrestrial Intelligence, SETI. So this is what's the difference between the old video that I showed that was grainy from 2 decades ago at the Naval Academy when we brought this team, and what we intend to do. Can I have the next slide? So getting back to the history, the Ghosts of Bellevue, GOB, was where the Capitol technology was formed in the 1920s in Anacostia. Bellevue in French is beautiful view, and beautiful view was Anacostia. And these sailors who came from Great Lakes, Michigan to DC had a master chief, a radio man by the name of Eugene T. Ritsky. So that's the picture of Mr. Ritsky in here. And this is the Bellevue Fables. So there's a book, and I can share it to people who are interested in reading the book. And it's all about dry humor, about living the life of hardship in DC. But these kids came from the Ghosts of Bellevue in the 1920s to mentor students, and Ritsky, the master chief, training these sailors who are on this side here. These sailors went on to work on big ticket items for the Navy, which is radar in World War II that won the war for us. And so they were involved at Chesapeake. They were involved in the early designs of then technology called wireless. So again, the birthplace of Capitol initially was at Bellevue, and that's where the site was called the Naval Research Labs. And NRL is famous for radar as the birthplace of it, and GPS. So the GPS is in your cell phones, and it was worked on in the 1940s for IFF early, mini track for detecting the Soviet vanguard, and in the 60s, radar GPS was formed, and the use of GPS became prevalent only in the late 1990s and 2000s. So if you want to read up on the small text there, it's what Ritsky taught. Just the little electrons ionize the air impedance, leaving the thing on negative bias. This will all cause the static that will take the Potomac River, and we won't get any signal. So it's all about wireless radio and signals that they were studying at Capitol, that Ritsky wrote the manuals, and people would come and do radio, the wireless radio, to perform music, and among other things, to get students involved in hands-on experience as they were learning at Capitol. So Eugene made money from the books that he wrote. He sold it to McGraw-Hill for engineering textbooks, and that with the money, he moved to 16th Street, DC, where until World War II, they were doing radar and at least electronics, initially through correspondence courses, but at their labs in DC. And then it moved to Kensington, and in the 70s to Laurel, where it's right now. So again, it's a valued history, and Mr. Ritsky and A. Hoyt Taylor met in Great Lakes, Michigan, where they had a Naval Academy-like structure in Great Lakes, and they moved it to DC. So Mr. Ritsky had all that vision and kept going on his idea of teaching sailors and corpsmen to be ready for the technology of the day. And this is the premise of Capitol, that we were there before. And if you go to that website on NIST, you'll see about hearing, about watching on the decades of video. But the key here is that it's experiential, it's hands-on, and students learned a lot in the labs. Can I have the next slide? So again, a bit of DC wireless history here. So in the 1906 time period, the Army lost its charter, and Navy was given the work to build on wireless. So a Navy lab was built at the National Institutes of Standards and Technology, NIST, which was in Tilden Street in DC. And it was called the Navy Radio Research under the Department of Commerce. And so there were people like A. Hoyt Taylor who were faculty there, and they allowed for hands-on research in the DC area. So the Navy, through this group in Anacostia, pioneered wireless communication for the President's State of the Union address using facilities in the Navy's facilities in Arlington, Virginia, DC, and at Annapolis. So when in 1912, when the Titanic sank and many people died, there was interest in understanding underwater signals. And then, of course, Louis Richardson created the first patent on echolocation. All of this, including Reginald Fessenden, who was a Canadian, to understand depth sounding for underwater communications, the Morse code, happened in southern Prince George's County. So these were the people who were working their experiments locally, and with the facility in Anacostia, the Navy lab, the students were given access to hands-on work. And with World War I over, the sonar and then the radar, the early part of radar, that work was done in the Potomac River, happened with Capitol students on campus. So the Navy radio station, NKF, fully functioned live music before the radio stations were around, the KDKAs. So Capitol students could go work in this medium called wireless throughout the US because they had the skills and be involved in it. So involved they were. So I have lots and lots of lab notebooks. I have lots and lots of pictures of students at different places working on radio and wireless and their interest in fixing things. And of course, when after the World War I, the Navy got the reparations of the blimps from Germany, the USS Shenandoah, the USS Los Angeles. So these blimps were manned by people who were at the Navy campus in Anacostia. And then, of course, in the late 20s, radar principles were discovered on the Potomac River of the work of A. Hoyt Taylor and his students with the with the sailors who were on campus with them. So the learning was difficult, but in World War II, the sonar buoys, the radar equipment on the Chesapeake Bay, all were man-tested by Capitol students when they were on 16th Street. So Ritsky ran the show, and he had graduates working in the war effort. So that's the glorious past of Capitol. And when NRL celebrates its 100th anniversary in 2023, Capitol should be proud of it because they were part of that, the Bellevue Radio School that existed in DC. And then Mr. Ritsky moved it to DC itself in 1927. So can I have the next slide, please? So coming to the challenge now, we call it, so we have a robot based on Raspberry Pi. A Raspberry Pi is this computer that you can buy for $30, even cheaper on Craigslist or wherever you want to buy them. It's about to learn coding on the Raspberry Pi and on a wheeled robot in a rugged terrain. That's a 12 by 12 arena, that's VEX or FTC arena, with 3 other robots. So the picture of the arena is on your left. So essentially you have an oval field. There will be a video of this in the next go around, and where you will be able to drive your robot fully autonomously. So you'll go through those steps of learning to code and drive this functioning robot. So what does the robot look like? So you can buy this commercially from Sphero. Sphero makes them, and the Raspberry Pi is on the Sphero right here. And then you can put on this robot, whatever sensors, whatever pieces that you will be learning in the next 2 classes, and make it a reality. So what will you get for this? Building this robot and testing, you'll get a certificate that you have done it. B, you will be working on your own lab notebook on the concepts that you have worked on. And what did you work with? Who is the work person you worked with? And how we can enable that. And the last part here is the designs, the mechanical designs. All of this can be publishable. and this will be the student's creation. And so we are there to help you form it along the way. And our job is to encourage you to think outside the box. So everyone who wants to learn gets this kit, the PiBot, and conform it to PiMars for a Martian land robot that you would be trying to locate. So our job is to encourage you to think outside the box. Our job is to enable you with whatever designs that you want to put in on the Raspberry Pi, which is this $30 device. And so we're going to provide you the resources. We're going to provide you the language, how you would get that started. Can I have the next slide? So the challenge here is called Capture the Flag. The flag is on the beacon that the Martian lander was lost, that was sent. And the aim is to locate the lander. So if you can, your robot can come close to the lander on this 12 by 12 arena, you have done it. So there will be 4 robots on the field. You don't need to have 4. And the whole idea is, can you learn to work as teams together? Can you find that beacon and hopefully locate the beacon in this irregular Martian terrain? So yes, you can, in the picture here, you see the International Space Station in its journey around the big blue planet Earth. What can you do outside? How can you think you can travel to Mars? And it's going to happen in our generation. Maybe Leslie and I will not be the ones building it, but you guys certainly will be. And our job is to create that passion on space robotics and get you involved. So the 12 by 12 arena is going to be mapped after the Martian terrain, irregular, with only certain regions that you can be able to navigate easily. So you can use that navigation space to understand where the field is and then start locating or missed Mars lander and go as close to it, and that's the capture part. You're not physically removing it from Mars or any of it. Just being a unit distance close to the lost lander is enough for capturing the flag. So the whole idea here is from 20 years from now, you will not be disappointed by the things you didn't do or then the ones you did, or throw off the bowline, sail away from the safe harbor, catch the trade winds, on your sails, explore, dream, and discover. That's what Mark Twain talked about. And this is what we want to enable you. The key here is that you are going to be working on this project, and our job is to get you in that mood of building the robot that moves with the code, with the sensors, that enables you to figure out how you would go towards it. Now, as we go to the next slide, I'm going to ask Leslie to talk about privacy after the importance of this notebook. So the key here is when you want to publish, you need to have a good notebook. So if you go to VEX or FTC or FRC, they insist on lab notebooks. But when you see the lab notebook, Cameron and I have seen hundreds of notebooks when we were judges, and they were all written in pencil or erased. That's not acceptable. You need to work your details on being attention to details, and you can't erase things. You can't staple things. The drawings are important. You have to get them written the way as you saw it. And then you need to have your friends witness it of what you have done, and that gets you credibility. So we want you to focus on documenting, and documenting gets you to start thinking about how you would publish when you come to senior years for your designs. So we want you to publish, and we are here to help you, but the key is we don't want you to waste data testing without having it documented. So proper documentation is what we are trying to encourage you guys to do. And then, of course, Here's a picture of a cartoon that my friend Mike Desch talks about all the time as part of Mazer. The world without the pun on civil engineers, engineers who are not civil. So you can build things and you will never understand what you have done. But if you have a good lab notebook that's well documented and the code that's well written and documented and put it in shared spaces like GitHub, which we'll be describing in our next 3 classes, you would be there. But then again, the key here is the ironclad rules of engineering. Keep it simple. You want to travel the Martian surface and you have about 60% that's not navigable. So you don't want to be stuck outside. So whatever designs you come up, you need to be making sure that you will not move from your safe zones to those domains where you get stranded yourself. So in the engineering version, you don't want to do anything that's complicated. You want to make it simple, and you have engineering in a form that's easily, you can see the structure being there from the get-go. So again, know your resources. Use it to your capability as well as you can. The better of the enemy is the good. So just, if you got something, be happy with it. Don't push your luck. Because you have timelines, you have end games that you need to work on. And I would suggest that you focus on that part. Before I go to the next ones, I would want Leslie to take over and talk about ethics and privacy.
Thank you, Vijay. So the great thing about being a mathematician is you get to change your career all the time. So when I retired from the government, I decided I needed to write a book on privacy, which I did. My book, called Privacy, Past, Present, and Future, was published this spring. It was published in May. And I approached it very much like a mathematician would. I wanted to understand what it was, and how we had inherited this value, where it came from in history. And then more importantly, to highlight what are the issues that we're struggling with now, and what are the issues for the future. You all are probably hearing there's a lot in the news about privacy right now. And I'm not going to dwell on the details, but let it just be said that at some point in the near future, the United States is going to get its act together and have a new federal privacy law. So why am I talking to you guys about this? The reason I'm talking to you guys about this is you have a responsibility as mathematicians, as engineers, as scientists, in the things you do, to make sure that you follow a code of professional conduct. And that might not be something that you've seen yet as freshmen at the university, or as first or second year students, or perhaps not something you think about in high school. But it's really important. Every professional organization has a code of ethics and professional conduct. And what do I mean by that? What I mean by that is the ways we all agree that we're going to behave. So for example, one of the best codes of ethics out there that I've seen was published by a group called the Association for Computing Machinery, which is the sort of one of the early professional organizations for computer science people. And what their ethics are, they're very simple. So their first ethic talks about contributing to society and human well-being, right? We don't want to do things with our engineering that hurt people. We don't want to set up devices that could hurt small children, for example, or that people could use to take advantage of other people. We don't want to hurt people. We also want to behave in honest and trustworthy ways. A particular hot button right now in our society is about being fair and not discriminating. We talk a lot about this in computer science design. Okay, sometimes when you implement an idea in computer science, you might not think about all the ways that it might not treat people dissimilar from yourself in a fair fashion. But you have a professional obligation as a working computer scientist or as an engineer to make sure that you don't devise these programs or design your computer programs or your technology in a way that it discriminates against other people. The final ideas in ethics are about respecting privacy and confidentiality. This is increasingly important today, especially as we start looking at augmented reality, virtual reality, collecting cognitive signals, collecting health information. There's been a lot of discussion about privacy related to COVID and proximity tracking in case you've been near somebody who turns out to have the COVID illness. This is really, really important. It's something we all have to be thinking about, is how much information should we be prepared to share? And how much of that information is just private to ourselves? And so I ask you all to sort of keep in the back of your mind that these are things you need to think about when you talk about designing technology, writing computer programs, using technology for that matter, right? If you go shopping on Amazon and Amazon collects a whole bunch of information about you and your shopping habits and what you're interested in, are you comfortable with the idea when Amazon ends up sharing that with other people? That's all I got on that. Vijay, back to you.
Leslie, can you also talk about your blogs that you have been working on?
Oh, I'd be happy to provide a link. So I started writing blogs. It's what I could do during the pandemic, was to reach out to my high school students that I tutor in STEM and write on subjects that are interesting to them. So I've tried to start writing technology blogs that talk about real world things. So recently, we've just had a series of 4 blogs about bicycles. We spent a lot of time talking about bicycles. Now, bicycles are actually pretty trivial technology compared to modern quantum computing devices, right? And yet there are some very sophisticated ideas about bicycles. They provide a wonderful example of looking at mechanical engineering challenges and physics challenges, how you transform from translational motion to rotational motion. What do gear ratios mean with bicycles? What are the frictional forces? So anyway, I will pass that link along for the STEM blog, to which I post once a week. Over to you, Vijay.
Thank you. And in conclusion, so we have come up with this PiMars as a robotics project that you can do. First robotics costs $20,000 for a team. And in COVID, it's not going to be viable. And VEX, they're all looking at possibilities of what they can do in distance. So with the Raspberry Pi, we should be able for you to code and test the designs and control all the robots. So we are here to help, and we hope that you guys take advantage of it. And the cost here is free. So you don't have to worry about funding on any of it. So I'm gonna leave this and give it the control to Cameron for Q&As. Thank you.
Thank you very much to our presenters. Really appreciate you guys taking some time to enlighten us. It looks like I need to go ahead and get signed up to do this as well. After all the robotics competitions, things that we've judged together, Vijay, it looks like something that I'm gonna have to get interested in. I do want to move us into the next phase, which will be our Q&A. As it stands right now, I don't see that we have any questions in the chat, but you're definitely able to ask those. Right now we have the mics and cameras disabled, but if you have questions for either Vijay or Leslie, this is the best time for you to ask those questions, and we can answer them in the order that they come in.
So while people are waiting for questions, so we have a maker space, and some of the students can come 3 days a week, Monday, Wednesday, and Friday, 3 to 7, and we as mentors meet on Saturdays. So again, everything is open, and so it's a Zoom call, or you can do however you want. And so we are all plugged in, and if you want to try out with the robots, the makerspace is open 24/7, 365 days a year.
Vijay, one question is that I have: how much experience do you have to have if I'm like myself, a policy guy, and I'm interested in getting into building robots to participate in this project? How much experience would I need?
So Leslie is a guinea pig. So Cameron, you will become one if you want to join in, and you'll learn a lot, because these students have a lot to teach us, because they have curious ways, like what we saw with First Robotics. The designs, my goodness, they are so interesting, and they put in the hours for that. So what we have is a platform to enable for their creative thoughts. So there's no expense, there's no cost. You need to come periodically. And what we plan to do end of October, after the sessions, is to open up for Girls Who Code, a STEM event for middle school girls. It's on Saturday, the 31st of October. And so we expect those middle school girls who will come for the full day session will be driving the robots in the arena.
That's awesome. That's awesome.
So Vijay, how many girls do we have now as opposed to boys? Is it harder for the girls?
That is the problem. We have about 6 girls signed up for the Girls Who Code. And what we are planning to do is, as more sign up, we will have multiple sessions. So we will have as activity zones in the space, and then bring in the girls to code and drive the robots eventually. So right now we have 6, but we hope to double it.
Great, great. I'm not seeing any questions come to the Q&A. I do want to be respectful of everyone's time, so we'll go ahead and move on to the last phases of our presentation here. And do know that you can continue to reach out after this to the presenters so that we can answer any questions that you may have to follow up with. As I mentioned earlier, this is the first in the series of our for this project certificate. Following each of our sessions, you'll be able to view these again on demand. And of course, we encourage you to view them again or share them with friends. Also, you can visit our webinars page, which is shown here on this slide, and you'll be able to take a look at our previous webinars and get a sense of what we also have upcoming. They will all take place on Fridays this fall. I want to say thank you again to our presenters. As I mentioned before the presentation, a link to the recording will be emailed to all registrants. So whether they're here or not, if you had friends that were going to be signing up who couldn't pull themselves away from their other responsibilities or tasks to attend today, you can definitely let them know that they'll be able to get that, and they'll have that in their inbox shortly. Also wanted to mention that this session does have, while this session does not have a certificate of completion, those who attend all 4 of the robotics project webinars on today, the 9th, the 23rd, and the 30th will earn a robotics project certificate, as well as be eligible to enter their robot in a virtual robotics competition later this fall. And this officially concludes our webinar. Watch out for a follow-up email with details on a link to the on-demand recording and more information on next week's session. Again, I want to thank Dr. Vijay Kowtha and Leslie Gruce for presenting today. On behalf of Capital Technology University, our webinar is now concluded. And this again is Cameron Newsom, Director of Admissions, saying thanks again and goodbye.
Thank you.
Thank you. Bye.
Bye.